In this video, we're going to look at complete and net ionic equations. Let's do this by looking at an example. We have a solution of ammonium sulfide reacts with a solution of tin for nitrate. Write a balanced chemical reaction for this process. So I'm going to write my reactants first. I have ammonium sulfide. So I'm going to need 2 ammonium and 1 sulfide. It is a solution, so I know that the state is aqueous. And that is going to react with tin 4 nitrate, which is also a solution, so the state is going to be aqueous. Now, to predict the products, I'm going to switch the tin and the ammonium. So tin is now going to be with sulfide, and ammonium is going to be with nitrate. I need to make sure I have charge neutral compounds. So tin is +4 and sulfide is -2. So that tells me that I need 2 sulfides. This is not a redox reaction, so I have to maintain the charges. I have to maintain that tin stays +4 and sulfide stays -2. Ammonium is +1, nitrate is -1, so that is good as it is written. Now I can look at the solubility rules. I know nitrates are always soluble, so are ammoniums. So that is going to be aqueous. Ammonium nitrate is going to be aqueous. If I look at the solubility rules for tin 4 sulfide, I see that sulfides are insoluble and tin is not one of the exceptions. So it is going to be insoluble. So this is a precipitation reaction where I form a solid. The last thing I need to do is balance this chemical reaction. I notice that I have 2 sulfurs here and only 1 sulfur here. So I'm going to balance out the sulfur by adding a 2. And in doing so, that made 4 ammoniums. So I'm going to put a 4 in front of my ammonium nitrate. And in doing that, I made the entire reaction balanced. My chemical equation is balanced. So this is my balanced chemical equation right here. Let's see how we can break it down. So here is my balanced chemical equation. Now, if something is in solution, it can break up into its ions if there are ions present. So things like aqueous ammonium sulfide can be broken up into ammonium ion, which is aqueous, and there are 4 of them, plus 2 sulfides, which is also aqueous. Tin 4 nitrate is aqueous, so I can break that up into its ions. Oh, whoops, that is a 4 plus, not a 2 plus, because we're dealing with tin 4 plus 4 nitrates, which is also aqueous. Now, if something is solid, it does not break up into its ions because it doesn't go into solution. So I'm going to leave my tin 4 sulfide together because it's not going to dissociate. It's not going to break up. And then my ammonium nitrate is aqueous, so it will break up into its ions. So in solution, we only have ions. So this is the complete ionic equation where we show that in solution, these ionic compounds are going to break up into ions. For the net ionic equation, you're going to write the chemistry that's going on. Okay, so we have something called a spectator ion. And a spectator ion is an ion that appears on both the reactant and product side of the reaction. So you can think of it, it's a spectator ion, it's watching the chemistry take place, it's not participating in the chemistry. Now, this is very important. You can cancel these spectator ions out only if they are the exact same on both sides of the chemical reaction. So on my reactant side, I have four ammonium. They are aqueous. My product side, I have four ammonium. So that would be an example of a spectator ion, and I can cancel those out. On my reactant side, I have two sulfide. On my product side, that sulfide is in a compound. It's not an ion, so this is not the same thing. I cannot cancel them out. Same with the tin. And then finally, the nitrate is on both sides, so I can cancel them out. The net ionic equation is going to be rewriting this with the spectator ions gone. So I'm going to have 10 4 plus aqueous plus two sulfides, also aqueous, yields 10 2 sulfide, which is a solid. Now, I know what you're thinking. Can you write it exactly as we have it up here, where you have 2 sulfide plus your 10 4 plus goes to your product? That's totally fine. I just am very used to seeing the cations first. Generally, when you see these types of precipitation net ionic equations, the cation is always listed first, but it doesn't matter to me at all if you just bring these straight down. They are the exact same thing. So this bottom one right here is the net ionic equation. Let's look at another example. We have a solution of silver sulfate, Ag2SO4, and it is a solution, so I know the state is aqueous. Reacts with a solution of lithium chloride. Lithium chloride is a solution, so it will also be aqueous. Now, in order to write that balanced chemical equation, I'm going to need to predict the products. So I can recognize that this is a double displacement reaction where lithium and silver are going to switch partners. So lithium is going to go with sulfate and silver is going to go with the chlorine. Sulfate is -2, lithium is +1, so that's why I put a Li2 there. Silver is +1, chloride is -1, so that is charge neutral as I have it written. Now, sulfates are generally soluble, and lithium is not one of the exceptions to make it insoluble, so it is going to stay in solution. Chlorides are generally soluble, but silver is one of the exceptions, so this is going to be solid. So this is going to be a precipitation reaction. Now I can go through and balance my chemical reaction. I have two silver on my reactant side, so I'm going to put a 2 in front of my silver chloride on my product side. And then I'm going to balance my chlorine by putting a 2 in front of the lithium chloride, and that balances out my lithium as well. So this is my complete chemical reaction. Now I can write my net or my ionic equation, and that's where we break up all of the aqueous solutions into their ions. So we have two silver ions plus a sulfate ion plus two lithium ions plus two chloride. The lithium sulfate is aqueous in our product side, so that is going to also break up. So we're going to have two lithium ions plus sulfate. Now, since the silver chloride is solid, it is going to not break up into its ions. It's going to stay the same. So we'll get plus two silver chlorides. This is our ionic equation. Remember, with your ionic equation, you're going to cancel out the spectator ions. So I have a sulfate on each side and I have a lithium ion on each side. Notice, I don't want you to get confused about this. I have silver on my reactant side and I also have silver on my product side. But this silver here is not the ion, it's part of the compound. So that is not going to break up. These are not, that's not going to break up, which means I don't have two silver ions. I have two silver chloride ionic compounds. So when I rewrite this with my spectator ions canceled out, we are going to get two silver ions plus two chlorides yields two silver chlorides. Now you can take this one step further and just write silver ion plus chloride yields silver chloride. For this class, it really doesn't matter if you simplify it or you don't. You can leave it unsimplified or you can simplify it, whatever makes the most sense in your brain. I want you to try this on your own. Go ahead and give it a try. And if you have questions, you can ask. And here are some more that you can go over and get lots and lots of practice with this.